Okay.
Okay, I'm available in my email if you need anything. Yeah.
Thank you.
Thank you, Kim. Have a good session. Bye-bye.
Hello, I'm connected. Uwe speaking.
Thank you so much for.
And Scott Madry is here. Hello, everybody. Hi, Kim.
Hi. Gallery. There, I can see you
Hi,
all.
everybody. This is Jakhou in Montreal.
Go ahead and just speak so we know that your audio is working, please. Leanne?
Hi, good afternoon or good morning. This is Leanne from South Africa.
And Tanja, can we hear you?
Hi, I'm here, Tanja. Nice to meet you.
Yeah,
Good morning, it's Lucy from Montreal.
fantastic. Sergio, Camacha-Lara?
Yes, I'm here from Mexico.
I'm gonna try to fix your name. I have no idea.
It's not hard. So we have to look here.
There's Foing in a class.
Hello, aloha. Okay, we are here from the EPFL, the École Polytechnique Fédérale of Lausanne. And so I have invited my engineer students from the course of Space System Design to listen to all your demands, and they are going to design possible space missions that could do the job. Thank you.
Thank you, Dr. Foing. Excuse me, this Dr. Pelton, Joe.
I can't get in.
Okay, you were in.
Just the meeting, but I can't unmute and I can't get my video.
I don't know, just could you try again, get out of the session and try again to,
Okay, I will try.
Oh,
wait a
there
second.
you are, Joe.
Oh.
Joe, I see you fine. You're there.
and your
Okay.
video and audio work great. Hello, Adriano. Dr.
Hello, Kim.
Ehrenfreund, welcome. Vid,
Hello.
Vid, can you say hello just so we know?
Yes, hello.
Excellent. Pardon me for a moment. It looks like everybody, almost everyone is here.
Could I just check my audio again?
Joe,
Is
we
my
can-
audio
Yes,
working?
yes.
We can hear you very well, Joe.
Great.
And
Joe,
welcome.
this is Tommaso.
Yes.
Yeah, I am not listed as a speaker.
Oh, Kim, can you answer that?
Yes. There have been some problems. The system has been a bit overwhelmed. You are listed in the formal list of speakers. Please, you will stay unmuted and please participate.
Let me
Hello.
check to make sure. Yeah.
Hello, Dr. DePopo.
Hi, how are you?
Hello. I'll answer that question in about 3 hours. Dr. Martinez, Peter Martinez.
Yes, hello, hi. Good to see you all. Good morning, good afternoon, good evening.
We cannot yet see you, Dr. Martinez.
I'm here.
Okay, there you are. Okay, great. We're still working on sound and audio check.
Okay.
So Sgobba, I thought he was added. Just a moment.
I'm going to mute and turn my camera off until I'm on air.
As you wish. Here we go.
That's Tommaso.
Yes.
Kim, were we able to solve Tanya's spelling
Yes.
problem?
Yes, I took care of it, Joe, and you can see her name is spelled correctly under her picture. Dr. Onios, please unmute yourself. There. Okay. Good. Could you speak, Temadayo?
Hello, good morning.
Thank you so much. We have many attendees this morning who are continuing to sign on. And it is, I believe we have all of our speakers audio and video checked. So I can't find, can anyone else see Joe? There he is. Okay, Dr. Pelton.
Well, I would just like to ask Vid to be on call if for some reason there's a power failure or something drops out to assume the chair in case something goes wrong.
Okay. All right, Joe, I think we're almost there. So go ahead and please, it's 9 o'clock, so please start the meeting.
Well, okay, but what about Pascale? Do we have her?
Yes. Hold on a second. She's trying to speak to you, just.
Unmute. So, Joe, I have very little voice. I'm trying to manage my session at 5 o'clock without dramatic coughing, but I'm quite how do you say, no COVID, yeah, but I have quite troubles to speak. So I will really try to concentrate on my session and not to be so vocal in the other sessions in order to survive today.
Good. Well, the only thing is that there's been some technical issues getting started, but it looks like we're going to be able to start on time. So I think I will be able to finish on time at 11 and turn it over to you.
Joe, Dr.
Yes.
Powell, please start the program.
Okay.
Your speakers are here.
Okay. Are we then ready to go live, in other words?
Yes. Go live. You are live.
Well, good afternoon, good morning, good evening, wherever you are on planet Earth. Welcome to this session on reimagining the space agenda. We feel space is very important to this UN Science Summit for several reasons. First of all, as we'll be exploring later in this session, the many ways that space systems are able for us to address the UN 17 sustainable goals with regard to our environment, with regard to our food and agriculture, with regard to health and education, with regard to emergency services, and many other ways space systems are vital to achieving the 17 goals. This will be chaired by my esteemed colleague, Dr. Pascale Ehrenfreund, who is president of the International Space University, and she'll be chairing that part of the session later on. But why space? I'd like to ask all of you, who here has been able to go into deep space and travel billions of kilometers into deep space to explore it? Many of you would say, well, that is just a few astronauts or cosmonauts or taikonauts. But no, everybody here has experienced that space travel because we are all a passenger on planet Earth, which is a 6 sextillion ton mud ball that carries all of our life. And this is important because if we imagine Earth as an apple, the rind of that apple would be the protective shielding that protects us from the many hazards of space, the coldness of space, the vacuum of space, and the many threats that are out there. So we're going to start this session by discussing the many threats to outer space by our distinguished panel of many 20 people from around the Earth. from Mexico and Africa, from Europe, from Canada, the US, and they are knowledgeable about the threats to space and what we can do to protect our planet better. And so I would like to ask all of our panelists, because we have so many of them and are so knowledgeable, to give us brief answers of 1 or 2 minutes to the extent possible. I'd like to start with my colleague, Sergio Camacha-Lara, who is the former director of the UN Office of Outer Space Affairs and also heads a UN institute in his home country. So Sergio, bring us up to date about the creation of the International Astronautical Warning Network and also the important Space Mission Planning Advisory Group that's been sanctioned by the UN due to your efforts and the efforts of the UN Committee on the Uses of Outer Space. Sergio, please.
Thank you very much for the introduction, Joe. Yes, I'm Sergio Camacho. I work at the National Institute for Astrophysics, Optics, and Electronics now. And I will briefly tell you about the establishment of the International Asteroid Warning Network and the Space Mission Planning Advisory Group. COPUS, the Committee on the Peaceful Use of Outer Space, established in 2002 an action team to study the risks that near-Earth asteroids mainly posed to Earth, and what work was being done internationally around the world. This action team made recommendations of what could be done and passed them over to the Committee on the Peaceful Use of Outer Space. The committee then established a working group in the Scientific and Technical Subcommittee. The Scientific and Technical Subcommittee studied the proposals that were made for 2 or 3 years and made a recommendation to establish what we now know as the International Asteroid Warning Network and the Space Mission Planning Advisory Group. The committee, COPUS, endorsed that recommendation and passed them to the General Assembly, where they were welcomed. And the General Assembly in December of 2013 made a recommendation that these 2 bodies, I1 and SEMPAGE, should be established. These bodies were established in January of 2015 and have been working throughout the period from 2014 to date. The 2 bodies, I1 and SEMPAGE, report to the Scientific and Technical Subcommittee on the work that they have done to date. And the Scientific and Technical Subcommittee makes their comments, recommendations. These are endorsed by COPUS, by the Committee on the Peaceful Use of Outer Space. And the
good, how are you?
Hello?
Go ahead, Sergio.
So the Scientific and Technical Subcommittee listens to the advances that are made and makes recommendations. Now, here is one very important thing that is still to be done. In case we have a credible threat of impact to Earth, it will be up to the governments to make that decision of what should be done. SEMPAGE would make these are the space agencies that are capable of carrying out a mission of deflection or mitigation mission, but it would be up to the governments to take that decision on whether to act and who should act. And I think because of the brevity of time, I would stop there. And if there are any questions now or later, I would be happy to address them. Thank you very much,
Sergio. We'll come back to various things that are happening, such as the DART experiment to deflect a small asteroid by the US, NASA, and by the Chinese initiative to create a system around the moon to perhaps deflect things. So these are national initiatives that will have to be coordinated. But let's go now to Uwe-Schrogl, who is from the European Space Agency and also president of the International Institute of Space Law. And I want to ask him, this type of UN initiatives that Sergio just discussed is all well and good, but the general public has very little awareness. And what can we do to increase the public awareness of the nature of space threats and to get them better aware of the need for action in this area?
Thank you, Joe. It's absolutely clear that we have to inform the public. Of course, we do not have to alarm the public, but the public should be aware of what is going on, what can happen, and what we should actually do. Of course, we are helped by Hollywood, and certainly you all know the movies around asteroids, impacts, deep impact in particular. So this certainly helps, but we as scientists and we as the experts, we of course have to bolster that with facts and with science. And there, I think nothing is better than something what really happens. And you mentioned it, DART, the experiment with an impact millions of kilometers away from Earth, which is observed by another satellite, accompanying satellite from the European Space Agency, actually happens tonight, this night, wherever you are on Earth, and you can follow that live. So this is, of course, something absolutely spectacular, which will inform the general public in a particularly interesting way. Now, what we further could do to make things, let's say, visible and interesting is, for example, to create either a video game or an app. Creating an app where you could then play around with what size of asteroid makes an impact where on Earth and which consequences that will have, how much flooding will take place, how much Earth and dust will go into the atmosphere. And then you can follow what is happening also to your place. I think this is something where you will then easily see and understand what is behind all this and what are the concrete consequences of such asteroid impacts. And speaking on behalf of the International Institute of Space Law, of course, we also have to see what are the legal aspects around this, and we have to see that everything which we will be conducting in this way is rule-based. So it respects the rule of law in outer space. And I'm sure that this is also something we have to communicate to the public, that this is well done and that it is done in view of being responsible. Thank you.
Well, next, we have an abundance of riches in terms of our panel, in that we have two former heads of the UN Office of Outer Space Affairs, and until very recently, that was Dr. Simonetta de Pippo. And she has some ideas about what the UN Office of Outer Space Affairs could be doing more and more effectively in this area. So I will call on her to give us her thoughts and ideas. Good morning, Simonetta, or good afternoon.
Good morning to all of you. And this is really a pleasure for me to be with all of you and trying really to advance on this topic. Well, Sergio before was very detailed in presenting the history and the background of the creation of these bodies, IU1 and SEMPAGE, which, by the way, started their activities during my tenure, because I started in March 2014 until March 2022. So for the full 8 years, I've been able really to follow and to push the activities, at least on the Office for Outer Space Affairs side of these two bodies. Well, I can tell you that both IU1 and SEMPAGE have been advancing a lot. So the original idea to develop these platforms for exchange of views, for coordination, for preparing space agencies and the community to a potential impact. I don't know if you want to mention that, but okay, potential impact with an asteroid. Well, I can report that it's been quite an interesting and good activity which has been done. In addition to that, I would like to mention that the Office for Outer Space Affairs was asked by member states to lead the permanent secretariat of these two bodies, in particular SEMPAGE, but IUN is in a way in coordination with that. Now, we've been doing, the Office for Outer Space Affairs, also some technical work, and even hosted the PDS, the Planetary Defense Conference. And in reality, what I believe is important to underline is that for member states, the more the Office for Outer Space Affairs can be really, let's say, can have, I don't want to say, I want to use the word power, but the possibility really to push internally and with the other stakeholders outside the topic, and this is true for planetary defense, but is in general true, this will advance more quickly the activities in the interest of member states. And also, on top of that, it's extremely important to underline that there are some parallel activities that the Office for Outer Space Affairs was conducting and is conducting with space agencies, part of SEMPAGE and IU1, because one of the issues that is really addressed very well by these groups is the communication plan in case of a potential crisis and the side of, the civil protection activities that you have to put in place in case of a potential impact. What I would like to underline again very quickly is that, the Office for Outer Space Affairs, in my humble opinion, can be even or more, let's say, more supportive member states if is able and is allowed to work more with the other stakeholders outside these groups in order to better support member states. Thank you.
Thank you. So the issue is now not only, what to do organizationally, but what should we be doing technically? Many people are concerned that when we started looking for asteroids, we started looking for those that were 1 kilometer in size and larger, and then we reduced it to 140 meters in size and larger. But it's observed that the asteroid strike that happened in 1908 in Siberia that destroyed an area size of, let's say, metropolitan Beijing or Paris or the entire Silicon Valley area of the United States, was only about 35 meters in size. And so many people feel we need better technology to address this search process. And so I would like to go to Bernard Foing, recently retired from the European Space Agency and president of the Space Renaissance International, to get some thoughts about what should we be doing better in terms of technology to locate cosmic threats and how we might better defend Earth against these threats. So Bernard. Are you still with us, Bernard?
With the help of my students from EPFL, but I think from all technical aspects, yes, we have an answer. First, I'm so excited about today. Actually, I proposed this date of today for our UN session because I had on the calendar the dark impact, which is due at 23:54 UT, that's 1:24 continental time in Europe. So we are going to watch that. And it was launched in November last year. And then we will have another mission from Europe to be launched in 2024 that will visit it in 2026 to look at the crime scene. And then you will know more about what is the effect of such a collision and also how to divert those type of objects. But now we are trying to survey all these potential objects that could have a regional devastating aspect. And so there is a program in China with a 1 meter telescope on the ground, but also we have some program in space. We have also the US Congress has put a goal to inventory 90% of objects which are above 140 meters that could have regional effect. And to this purpose, there is a mission which is in the making that that is going to be launched in a few years. That will have some measurement in the infrared that allows to have access also to the size of the bodies and also to some of its nature. And we will have 90% of this object surveyed. Another way is also to put a telescope on the moon from where you can see even objects that come from the inner part of the solar system. So a number of then effort to study the nature of this object, also by mission institute, looking at what they are made of, their composition, in order to also be able to model what would be the effect of such bodies when they do an atmospheric entry or even when they hit the surface of the Earth. So that's one of the danger of coming from space. Another type of danger is those that come from the sun itself. And for this, the various agencies have a kind of space safety program that includes both protection from asteroid impact, but also monitoring the effect of the space weather. And sometimes you have a very disruptive event, so coronal mass ejection and the storms that affect the Earth, but magnetosphere, and that can be a danger to our whole satellite infrastructure in orbit, also some installation on the surface of the Earth, hydroelectric, electric installation, and also, of course, the safety of some of our astronauts. So they are building, for instance, in Europe, building on the development with the science that we have done with the Solar Heliospheric Observatory, SOHO, with the Solar Orbiter, with the PROBA mission that was monitoring the sun. We are looking to establish eventually a sentinel that will be on the Lagrangian point, 1.5 million kilometers from Earth, and that will give us some warning if there is, for instance, some storm of particles that would reach the magnetosphere of the Earth. So that's what ESA is doing, but also NASA and other space agencies are contributing to this international space weather effort.
Thank you, Bernard. I'm also working with my colleague, the former chief scientist of NASA, about maybe to create an electromagnetic shield at that location out there 1.5 million kilometers from Earth. But,
yeah, we have to look at the feasibility, at the numbers, but okay, I think any idea should be exploited. Here I am with a group of young students. Maybe we could challenge them to design some mission that could be precursor for such endeavors.
Great idea. I proposed a study at the ISU for that as well. But we have now looked at sort of the institutional arrangements and some of the technical aspects. A key part of the discussion is the legal aspects and what can we actually do to be institutionally organize to address this issue. So I'd like to ask my good friend, Dr. Ram Jakhou of the McGill Institute of Air and Space Law, what could we be doing better to organize ourselves legally to address cosmic hazards and threats, and to work to better organize ourselves globally to work together on this hazard that's a threat to the entire world. So, Ram.
Thank you very much, Joe. It's always a pleasure to work with you, and thank you for inviting me. I'll just pick up from the point which Sergio and KV left. I think, but before I address that issue, I think we should realize that to a large extent, natural cosmic hazards cannot be avoided. You can't really prevent them. In sort of what you can do is simply assess where they are, detect them, assess the risk, and take some measures to deflect them somewhere that you can somewhat save. So what the efforts have to be made, what you call is kind of planetary defense in certain way. Now, to undertake that kind of action, the two things are very important, that kind of action has to be taken at international level. Global community has to take. One nation, doesn't matter how strong, how rich that country is, cannot do everything. Secondly, it has to be absolutely within the law, or if there's no law, create the law. And that's the point Dr. Schrogl made earlier. So that's very, very important. Now, it is known that the efforts to track and identify near-Earth orbit has been going on, and the good work is being done. A number of people are detecting and assessing the risks, but there is a need for a greater coordination of efforts with respect to sort of larger areas, space weather, cosmic hazards, solar flares, and other matters or other issues or other phenomena which affect the whole issue of cosmic hazard, something along those lines. Now, what is really the current international law or current international regulatory system doesn't really address this issue. What we have is only the 1967 Outer Space Treaty, which is very general. So in certain ways, the current legal regime is actually a barrier for specific legal action to be taken. So one has to look what is available, what are the barriers this regulatory system provides, and try to address them. Just to take just one simple example, if an institution or a government want to use nuclear power or nuclear weapons to deflect the oncoming asteroids, and there could be serious legal implications of that. So what I'm saying is we need to assess the current legal regime to assess what are the gaps are there, what are the barriers in that way. So and in that also, the United Nations, COPIUS, of course, is very important institution in the United Nations. But to me, I think the Security Council has to be very much in line with the whole thing, because this is a threat to international peace and security. And we have been understanding that the threat to the very survival of humanity. So not only the COPIUS, but at the Security Council level, things need to be addressed in that way. And that brings us to see what kind of mechanism, what kind of regulatory system, kind of cooperative arrangement could be in place. So of course, there are a number of proposals which have been put together. And Joe, you and I have been working on the idea of have some kind of international sustainability treaty or agreement to identify potential mass extinction threats and creating a systematic approach and working of these threats. Could be including cosmic threats, asteroids and comets or major solar flares. So one has to have a little broader picture, a kind of framework, not necessarily an organization, but framework understanding and possibly looking at what can be or what could be done, and also who should take this action. That identification has to be done. Now that brings to the last point where I say, who will pay for all that? And where the money has to come from. My personal view is that naturally it is at that level, the governments, particularly the major space powers or rich countries have to take the lead and provide funding for this kind of arrangement. And then of course could be develop something governments and intergovernmental organization. And also say number of private companies are very much interested in this field, and the foundations or private individuals can provide that kind of money. But beside that, if there is no international organization, perhaps there is no need at this stage, a kind of non-profit or charitable organization could be created for the simple reason of purpose of coordinating the effort, studying these things, and moving forward, and then identifying who should take the risk and how to reduce the legal barriers, and also how to protect the service providers, if I can use, particularly from liability point of view on all those issues. So this is where I stop.
So thank you very much, Ram. I would just note for those who might be interested, we did do a book together, Ram and I, called Space Systems and Sustainability. And we were looking at not only space hazards, but also pandemics and many other threats that we thought could be looked at under some sort of global framework. So I would like to also call on Dr. Lucy Stojak, who for many years was chair of a advisory committee to the Canadian government on space issues, and is also a space lawyer, to add some thoughts about what could we be doing better globally to address these issues and to make some specific actions to protect planet Earth.
Thanks very much, Joe. Always a pleasure to see you, and very honored to have been invited to take part in this panel. Before I address your question, I want to share one piece of information about the DART mission that I'm particularly proud of, which is the following. The engineer who is in charge and leading the team on the navigation team for DART is a McGill graduate from the engineering school. She then did several degrees in the US, and she's also an alumna of the International Space University in the 2004 session. So she's getting a lot of news coverage here in Montreal. So I wanted to share that with my McGill and ISU colleagues on the line here. So I'd like to maybe try joining some of the dots that the previous speakers made. I think, as was highlighted by everyone, planetary defense is a global problem. It needs a global solution, and it ultimately will need global governance. What we see now are many different voices and maybe conversations that are taking place. The UN, as Sergio mentioned, with the network, there are governments and space agencies that are involved to bigger or lesser degrees, some not at all, some very actively involved. So I would very much agree with Ram that one of the first things that is needed is a coordinating body, perhaps even starting with a coordinating body between the space agencies. I target the space agencies in particular at the start of these comments because they have the benefit of dealing both with the scientific teams in their countries, but also with the people from government and the diplomats who go to international fora or who take participation in some of the research that's going on. So right now, I think there's a need to join the civic voices, the researchers, the diplomats in more of a network type of arrangement. I think we could be inspired by what other sectors in the world are doing. And I'd highlight one example around ecosystems of innovation and the importance of co-innovating. I think for a challenge like planetary defense, we already see that there are different communities that exist. There's the legal community that's looking at the potential challenges, the technical community. There is this wonderful new center at École Polytechnique Fédérale de Lausanne that will be gathering information and rating space sustainability. So there's a need to get all of these voices to speak together and to each other to co-innovate. I think this is too big of a problem to be left to communities to work in silos. And so what we need perhaps is to create a new ecosystem where members of government, the public sector, space industry, on an ongoing basis. Planetary defense, the hit by a cosmic hazard is not scheduled for tomorrow. So there's a challenge of longevity and of continuing interest and of continuing passing on the knowledge and not just perhaps sporadically speaking at different fora on the issue. So I think that there's a need to coalesce the conversations on a long-term basis. And I also agree with Ram that funding this type of discussion and this type of ecosystem will be key. And perhaps to end, I believe that DART, at least for a short window of opportunity, will bring the importance to the public and also perhaps to governments in view of the nature of the results that DART will be bringing forward. Thank you.
Thank you very much, Lucy. We unfortunately have a limited time to discuss all of the issues, and so now we're going to move on to solar storm issues, which are also a bigger issue in my mind in terms of urgency, because that's probably the solar threat that could be the most immediate in terms of its impact on planet Earth. But before we go on, I would just note that we'll try to do a paper to summarize some of the excellent points that have been made today, and people can amplify them in the written version. But before we go on to the next issue of solar threats, I'd like to ask Kim Degnan whether we have any questions from the audience that we might need to respond to before we do.
Nothing urgent at the moment, Dr. Pelton. However, Dr. Beldavs has to leave in a few minutes, so perhaps you can move on to him.
Right. Okay. Well, the next question is for my good friend Beldavs of Latvia, who is one of the leading technologists and scientists in Riga, Latvia, and he has followed solar storms and issues. Particularly, we've discussed the idea of better protection of electromagnetic transformer systems through the better equipment of these systems against solar flares. So, Vid, could you address what you thought the major issues there are and what we might do to protect against them?
Okay, I think this problem bears a lot of similarity to the EMP problem. And the US Congress created an EMP commission in 2001. And the idea there, start my video, the idea is that EMP pulses from a thermonuclear device detonated, let's say, above the United States, really would have probably a comparable impact to what people view could be from a Carrington scale event that happened in 1856, when there was a global impact from a coronal mass ejection. I think this is a problem that can be quite complex, because the idea of transformers buttressing systems, that has been looked at for these kinds of issues. In Texas, actually, recently, very recently, when there were power outages, it was specifically this kind of device or technology that caused the problems, because as solar energy fields came on board, okay, they triggered systems, and then this triggered shutdowns that lasted perhaps 6 minutes or so, but that had a very bad impact on many devices in the area. What I think could be useful is to join this effort with the EMP Commission work, which became quite active again in 2017 with the scare from the North Korean nuclear detonation. And right now we have a similar scare due to the Russian Federation's actions and the threat of using nuclear devices. So I think that threat is almost immediate. We do have a very high level of solar activity at this time. I believe that will continue for some years. And so we have to prepare for the other threat. What I would suggest is this, that ACES and other organizations turn to the Electrical Power Research Institute, which is the American utility joint effort to research problems like this and basically to prepare the industry. Okay, that would could take care of the problem between the different grids and the utility systems. There are certainly broader problems which the EPRI would not address, and that would be what happens to our satellite systems. To a degree, that has been addressed by, I believe, also the EMP Commission and what they've attempted to do. So I believe there are mechanisms out there that I think we could turn to. And I think if the EMP Commission realized that some of their work is very similar to what President Obama authorized in his executive order in 2016 October, which was basically on this threat of the coronal mass ejection. And in that case, yeah, there was supposed to be a commission established and working, and within 90 days, but when the next president came in, all that work was essentially ignored. Okay, at this point, we can no longer ignore it for the three threats which can have somewhat similar effects. No scientist has really observed a Carrington scale event. Okay, we don't have the data. That may have other impacts than just the EMP pulse type of impact on national grids. The electromagnetic, the magnetic effects and on various devices that exist now that were not around 150 years ago, there needs to be a lot more research on that. So I think the other recommendation would be we need research on these effects and what happens to devices and specific technologies. So there we need to encourage the research on the impact effects of these kind of incidents, or in the case of the North Koreans or the Russians now, of actual thermonuclear detonation to basically wipe out the US communications infrastructure, perhaps with a few thermonuclear devices in certain spots in orbit. So I think those threats are quite near, and but they have similar impacts, and I think that's where we need some very, very strong research at this point. And that could be said like Obama did in October of 2016, is we need reports by 90 days, this. That never happened. That probably should happen now.
Well, thank you very much, Vid. Just to set what we're talking about in context, in 1859, when this occurred, telegraph offices caught on fire. The northern lights came down to Cuba and Hawaii, and we basically, if that were to happen today, it probably would take out electrical power systems, would destroy pipeline systems around the world. We did have the Montreal event in the 1980s, where power was taken out between Chicago and Montreal. And then we had the event in Scandinavia called the Halloween event that took out power in Scandinavia. So these are real events, and a really big event like the Carrington event that seems to happen every 150 years. So we're overdue to address this issue. And the thought is some of the transformer systems have been protected, but that we could use capacitors and other systems to protect against either electromagnetic pulse explosion or a major solar storm. So I'd now like to go to Leanne McKinnell from South Africa. She is with the South African National Space Agency, and to say that many people think this is an issue that only developed countries need to worry about. But actually, perhaps many of the world's most vulnerable electrical systems are in developed countries, which have not been equipped with capacitors or other heavy-duty circuit breaker systems. So Leanne, could you comment about this issue and what we might be able to do?
Thank you very much, Dr. Pelton, and good afternoon to the colleagues and people online. So we know that space weather effects are more severe at high latitudes due to the dipole structure of the geomagnetic field. Low and middle latitudes are, to some extent, protected from the most severe induced currents experienced in the auroral zone. However, damage to network infrastructure has been reported in various middle latitude regions, such as Southern Europe and the Southern United States, Australasia, and southern states of South America. These areas are at similar geomagnetic latitude to southern African states and far northern reaches of the African continent. And I'm speaking purely about the African continent now, being as that's what I bring to the party. Furthermore, the impact of geomagnetically induced currents on grid infrastructure is not only a function of geomagnetic disturbance intensity, but also depends on regional conductivity structures and network characteristics. Ground conductivity up to a depth of tens of meters determine the induced electric field amplitude and direction, and the relative orientation of transmission lines with respect to the E-field vector determines the current induced in the line. Once the current is induced, it is the state of network infrastructure that determines the practical effect of the induced current. Vulnerable transformer layout and design, overloaded networks, and aging infrastructure all contribute to the overall vulnerability of a network. Furthermore, electric field induction also scales with transmission line length, so long transmission lines are typical for Southern Africa. All lower latitude regions need to take heed of geomagnetic disturbances, as the combination of high population density, aging infrastructure, and overloaded power grids all increase the susceptibility in the face of an intense solar cycle 25. And while we know that the official prediction of solar's 25 seems to be underestimating the current cycle, so it was predicted to be a mild cycle, but it looks like it's going to be more intense, so the impact is going to be even more than we anticipated. So therefore, long-term risk modeling, better understanding and forecasting of middle and low latitude geomagnetic disturbances, and the hardening of grid infrastructure or mitigation steps that should be taken now to avert future disasters. And I want to concur with the speaker before me that we need to encourage further research in this area. We need to understand and know what we're dealing with, and then we need to develop awareness. It is critical that we talk to users on the African continent and make them understand the vulnerabilities that their networks are going to face from space weather. South Africa alone is currently experiencing an overloaded electrical grid network. And in fact, I'm about to lose power for 30 seconds just as, to prove that point. And the impact of space weather will even greater compromise the system. So thank you very much. I think that's all on that question. Thank you.
Thank you very much, Leanne. I would like to now go to my friend and colleague, Tommaso Oniofsson, who heads Space in Africa, and ask him that general question of that: to what extent is space relevant to African concerns, and to what extent do we need to protect Earth and our electronic infrastructure, because it's not only, you know, electrical systems, but it's also satellites, it's also pipelines, it's also automatic controls that control elevators. A huge Carrington type event could be destructive to almost all aspects of our planet and all of the infrastructure on which so many jobs now depend around planet Earth. So, Tommaso, could you give your perspectives on some of these issues? You have to unmute yourself too. Tommaso, can we hear you? I think that he may not be connected to the system at this time. So we need to go on to the other part of the program. And again, ask if there are any questions related to either asteroids or solar storms and what we could be doing about them.
Yes.
Again, Kim, do we have any questions?
Yes, Joe, we have a question from Dr. Foing and his students. I'm going to ask Dr. Foing if you could please ask the question and unmute yourself.
Okay, so yeah, I am with some students. Oh, do you hear me? Yeah. Oh, okay. We are with. Do you hear me? Yes.
We can hear you. We cannot see you. Please
okay.
Unmute. Start your video.
Yeah. We have some students that are they have tasked in 15 weeks to design an individual space mission, and so they are collecting demands, input from the community on in what topic they could design some mission that would be useful in the areas of space defense, in the area of space weather, or in sustaining, addressing sustainable development goals. So if you have any suggestion of ideas that they could catch up, and then they could use their engineering design skills to eventually study in detail some of these concepts. So we are, at the end, we are going to compile some of the ideas that they have listened to, and they may come with some concept of small and middle-class missions that could address those goals.
Well, I would just like to suggest that one of the things that has been suggested is the idea of electromagnetic shield that could be positioned at the so-called L1 position, where the gravitational pull of Earth and Sun tend to cancel each other out, and that could be used to protect us against Earth blast from the Sun. The interesting thing is my colleague Jim Green of NASA has thought that if we did a similar thing for Mars, we could actually create an atmosphere for Mars, because it's the solar wind and blasts from the sun that strips away the atmosphere of Mars. So this is kind of a 1-2 issue. Could we do it for Earth, and could we also do it for Mars? So I hope maybe the students might look at both of those issues.
I think this is more a scientific challenge. I made myself a calculation, and I calculated that it would take 1 billion years, you know, if you have such a system to revitalize the ancient atmosphere. So we have really to look at the numbers. In the case of the EPFL students, they are looking at a small middle-class engineering spacecraft that could address, you know, some questions. So they could have a telescope surveying some of the smaller near-Earth approaching object that could be dangerous. They could also have a mission that would characterize some individual class of object. They could have also some sentinel that look at the sun in various places of the solar system, or any other ideas that they are going to look at. They might really also monitor some effect of such impact on the moon, that's possible as well, and then look like we are going to do with a DART impact. We are going to impact, and then we are going to look at the effect. We have also on the moon all the time some impact, like typically there is 1 kilogram per day falling and making a crater of 10 meters. So we could have also various scientific and engineering studies that could address this topic of the effect of impact and also mitigation measures. Another possibility is to go on the surface of an asteroid and then look at the effects of the impact.
Joe?
Just a final note that there was the project from the B612 Foundation that looked at the so-called Sentinel satellite that was in an orbit similar to that of Venus, that was a very innovative concept that never got executed. So they might look at that project to see whether it still might be relevant as well.
Okay.
So,
Dr. Pelton, we have another, just two quick, we have another question that is addressed, but I want to make it clear. We have several people who are attendees who are interested in hearing more about the possible impact of asteroids on Earth's satellite systems. And also, Dr. Pelton, to remind you that Dr. Martinez has limited time. So
right,
please.
okay. Well, I think that maybe we need to go on then to Dr. Martinez and then come back to those questions toward the end of the session. So the next topic that we have of concern is orbital space debris. And so perhaps we'll start with Dr. Martinez in terms of the extent of the issue, what can be done to address this issue in terms of space traffic management. And after that, we'll go to Tommaso Sgobba of the International Association for the Advancement of Space Safety. So Peter Martinez, can you give us your perspective?
Thank you, Joe, for inviting me to participate in this event this morning or evening, wherever you all may be. Great to see you all online and great conversation. So you mentioned space traffic management and space debris in your question, and I will begin with the observation that of the more than 36,000 or so space objects that are tracked, which are about the size of a tennis ball or larger, only a small percentage actually have the ability to move to avoid a collision. We're talking around the 10–13% fraction. And any future space traffic management regime will have to cope with this reality that we cannot coordinate space traffic for the vast majority of trackable objects. We just have to get out of their way to avoid a collision. Now, coming to the second part of your question about what can be done to limit the increase of debris, there are several things that can be immediately done. Firstly, over the years, the world has adopted a series of best practice space debris mitigation guidelines. And the first thing we can all collectively do is to improve our adherence to the existing best practices for debris mitigation, which has improved over the years, but is still far from universal. And we can call on all space actors to do their best to implement the existing space debris mitigation standards and guidelines. The second thing that we can all do is to avoid creating more debris through explosions and debris producing events in orbit. So spacecraft operators can passivate their spacecraft at end of life by venting propellants and draining electrical energy and other sources of energy from their spacecraft, which can lead to these breakup events. Thirdly, Spacecraft in all orbits, but particularly those in LEO, which is the most crowded orbital environment, should be actively disposed at the end of their life. In my view, the existing 25-year guideline is too long for today's congested space environment, and spacecraft in low Earth orbit should be disposed of in a shortened time of, say, 1 to 5 years. And of course, fourthly, what we are most concerned about are the catastrophic debris-producing events, such as collisions or explosions of upper stages in orbit. We can avoid explosions by passivating spacecraft or deorbiting upper stages, but the most concerning debris-producing events are those that are produced by kinetic anti-satellite tests, which are entirely unavoidable. Which are entirely avoidable. These types of demonstrations produce massive amounts of orbits and are being increasingly seen as irresponsible actions in space. Earlier this year, the United States made a unilateral declaration that it would not perform any more direct ascent anti-satellite tests in low Earth orbit, and similar commitments have already been made by Canada, Germany, Japan, and New Zealand, and we hope there will be more states to join this so that it becomes a norm not to conduct such tests in future. The fifth point is that in the longer term, we will need to remove legacy debris from orbit, but in my view, this is probably still some time away, as it will only become viable once there are commercial operators who can provide an end-of-life disposal or debris removal service on a commercial basis. And finally, I just want to end by remarking on the recent legislative developments in the US. A few weeks ago, US Senators Hickenlooper, Loomis, Cantwell, and Wicker introduced the Orbital Sustainability Act, also known as the Orbits Act, which is a bipartisan bill that, if passed, will create a demonstration program for actively removing debris from space and improving space traffic coordination based on guidelines and best practices used by government and commercial space industry operators. So these are some of the things that are happening and will be happening in the near future, and steps that we should take to safeguard the space environment from unchecked debris proliferation. Thank you.
Thanks, Peter. I do think that we do try to find global solutions, but sometimes it is important for national initiatives to set a standard or a goal to be observed by others. Basically, the French developed their space safety act that set new standards and so on. And if the US and other countries can agree on best practices to remove debris and so on, I think that sometimes you can build from the bottom up as well as from the top down in terms of finding global solutions. I'd next like to go to Tommaso Sgobba. He has been a leader in the formation of the International Association for the Advancement of Space Safety, and is quite an expert on orbital space debris, the problems and possible solutions, particularly in terms of the possibility for some sort of a space traffic management system. So, Tommaso, could you please enlighten us?
Thank you, Joe, for the very nice introduction. I would like to talk briefly about the space debris, but trying to change a little bit the perspective. I would start with ASAT, anti-satellite test. And I would like to say that there is a growing and I would say well-established support for the idea that ASAT test should be forbidden. But we should do something more, because as we can see and we are seeing in these days, war can truly happen at any time. And we should go beyond the idea of testing weapons, but we should embrace the idea of banning all the anti-satellites weapons, because it is of very little comfort to think that we can avoid perhaps one test every 2-3 years, but then allow a massive destruction of the Earth environment should the war expand to space. So in a matter of hours, we may lose completely the possibility of accessing space. So something that we are pushing nowadays in the association, IAAS, is the idea that we should be banning anti-satellite weapons, not only test. And this is the first change of perspective that I would like to offer to our participants today. The other comment I would like to make on space debris is about why we are not successful with space debris. The mitigation of space debris, with the removal of space debris. And for me, the problem lies in the way we are approaching the issue. In recent years, the idea has caught on that space industry may self-regulate internationally by developing voluntary consensus standards for safety. So far, the approach seems to be not working because of lack of enforcement mechanism, as proven by the failure of ISO space debris mitigation measures. We have to realize that a standard becomes truly a standard only the moment in which it is enforced. An ISO standard becomes an ISO standard if there is, for example, a contract that enforces it, if there is a regulation that enforces it. As long as this ISO standard is just a document which is the result of the good intention and effort of a group of experts, this is in all a sense not a standard, but it is a guideline. It's something that is left to the user to implement if they wish. Here goes the other comment which I would like to make. Everything that we discuss and tend to rationalize in relation to space debris is related to the idea of self-interest. Industry have a self-interest in preserving the operational environment of Earth. Industry has a self-interest not to build airplanes which kill the customers. This is for sure, the rationale, the basic rationale. Drivers have a self-interest not to be killed while driving, but there are drivers which drive drunk and so on. So we have to accept the idea that for things to happen, we need regulation. Now, what is the difference between the regulation and a standard? The regulation is something that is there to make sure that people will do what is required to be done. Okay, so the regulation, the difference between regulation and voluntary standard, etc., is that the regulation, the purpose of regulation is to make sure that people do something that they may not otherwise do, or at least not automatically do. Traditional regulations are based on the principle of command and control. So you have to have prescriptive rules, define what the people must comply with, or face penalties, financial or custodial penalties. So the key interest of the regulator is that the rules are effective and efficient, so the rules are applied. So this is the message that I wanted to push forward, and also underline another aspect. We talk about standard, mitigation standard, the 25 years rule, the de-energization rule about batteries and tanks, etc. But please note that these are truly goals, not rules. They don't tell you how to do it. What you need to do to really de-energize a tank. So what is the level of, let's say, the amount of remaining fuel that is within the acceptable level? It is not prescribed. It's something to be decided on a case-by-case basis. So there is a passage to be made between regulation, between voluntary standard, performance-oriented standard, the one that tells you what you have to do, but not how to do it, and regulation and prescriptive norms. The only way, personally, I see for making this happen is to do for space what is done normally for ships, for airplanes, for traffic management of airplane, for traffic management of ships, and is basically to have an intervention of the international government community. So we need an organization like ICAO for aviation, which basically has the mission to make principle into applicable norms, and then will be up to the governments which have committed for that purpose to implement the norms that have been agreed at an international level. Only in that moment we will be able to prescribe a simple rule, but an expensive rule, that is remove everything that you launch. It's something very straightforward, very simple. If you want to stop the problem of space debris, whatever goes to space has to be removed at the end of the mission. But implementing these simple rules requires let's say, decision maker and international agreement on doing so. Thank you very much for your attention.
Thank you, Tommaso. I do think that it is important to recognize that to make this work, each country's, if you will, control of their aviation and their space systems could take responsibility to regulate things at a national level, but that we also need this international entity to coordinate the actions of all the countries to control their space and their space debris. I would just note that Adriano Autino, who was the founding president of our sister organization, Space Renaissance International, of which Dr. Foing is the current president, has suggested it's not only just a matter of removal of space debris, but the idea that perhaps we could repurpose debris in orbit so that it could be reutilized in space. So rather than just removal, we could also be reutilizing this mass that's up in orbit, which was very expensive to launch in the first place. So that's a very interesting idea that hopefully can be pursued going forward. But I'd like to also go back to call on Professor Schrogl to see what ideas he has in terms of, again, international cooperation to build towards space traffic management or other solutions. So are you still there?
Yes, I am, Joe. Yep,
please,
thank you.
go ahead.
Thank you very much. May I first say a few words on space debris, because this could build on what Peter and the other previous speakers have said, in particular also what IASS is doing, as mentioned by Tommaso. Now, from a legal perspective, we would, of course, like to see, and we would be happy to work on binding rules. So far, we only have soft law and arrangements, and this is not enough. Sooner or later, we have to have binding rules for space debris mitigation, and we have to have a legal framework, a binding legal framework also for the removal of space debris. And this can only come through multilateral negotiations, because it should be and has to be universal. Also in order not to allow discrepancies in the competitiveness of the various actors in outer space. Of course, there can be good examples and let's say countries or groups of countries going ahead. ESA, for example, has come up with the initiative Debris Zero, which means there will be no debris produced, not one single piece of debris produced from 2030 onwards. And if there is one element of debris, ESA will remove another element. So this can be good examples for others also to follow, but they cannot replace the binding, multilaterally developed rules which we have to come up with in the field of debris mitigation and debris removal. And sooner or later, but this is something very tricky in international law, we have to come to enforcement. There is nothing which can be enforced in international space law so far, but we also have to learn from other fields of international law where enforcement is possible. And the last point I want to mention is that member states of the United Nations, and in particular those who are state parties to the Outer Space Treaty, bear a particular responsibility also for the sustainable uses of outer space. And this they have to do through national space legislation. National space legislation, which comprises in particular the authorization of private space activities. And the authorization of such activities should or even has to come with a sound way of regulating how the sustainability for outer space can be achieved. So it means very tough, and I clearly state that, very tough space debris mitigation guidelines for the private actors under their jurisdiction. And this should be done in a harmonized way by all the countries. So we have a set of opportunities, possibilities, and also options which we should take, where international space law making should go hand in hand with national space legislation, which, and this is very important, also can be enforced by these countries. So I'm quite optimistic that we make bigger steps forward, also in view of then allowing this as a stepping stone for space traffic management, which will come, and where I'm absolutely convinced that we have good ideas, but also good arguments to have such space traffic management, I hope, from 2030 in place in order to secure the safe use of outer space. Thank you.
Thank you very much. As I mentioned earlier, the French space law basically created their own national penalties for violation of problems. So I do think the last point you make is very important, that if we can get nations to create penalties and enforcement procedures and coordinate them globally, we can build a system from the bottom up. I'd like to actually go back to Simonetta, the people. Oh, hello?
Yes, when I show up video, it's because I'm trying to tell you that Dr. Camacha-Lara has a comment, and Dr. Autino both have comments on this subject.
Right. Well, we'll go to Simonetta first, but I was actually planning to go to Sergio next in any event. So Simonetta, go ahead, and then Sergio.
Well, no, I mean, I can only comment that I really share what just Uwe said. Law enforcement is probably one of the biggest issue that at the international level, from a multilateral perspective, is not so easy to discuss and solve, but it's also true that in other fields, this is applied already. Well, I would like to mention that having spent 8 full years serving the Committee on the Peaceful Uses of Outer Space, when I arrived was 76 member states, and when I left was 100, so with an increase of 32%. Well, this is quite interesting because it means that we have more and more member states and more players at the table, which is a good sign. Because clearly we need to have all a common responsible behavior, and the more players we have at the table for discussion under the umbrella of the UN, the better it is. So you may say that 100 is still more or less half out of 193 member states of the United Nations. At the same time, 32% increase in just few years, in my opinion, shows that we are on the right track. And so we have to push and push again member states, because the private sector, which is also an important stakeholder in the picture, well, the more the authorities at government level in the various member states are able to, let's say, monitor and license properly, I mean, they are private operators, the more we will go in the right direction. I really welcome the initiatives of France on one side, the European Space Agency and others. But, you know, these are for sure the main spacefaring countries. And they've been always very, let's say, strict in following the treaties, the principles, and the guidelines. However, we have other member states which may be new in the picture, which not necessarily have a national level national space laws approved, or a national space office or agency able then to do the job that is instead, let's say, well developed in other countries. So there is also an issue of capacity building. And that's also the reason why the UN started, I mean, the Office for Outer Space Affairs started just a few years ago, some capacity building activities and training courses for new players in this field. So just to say that there are a lot of elements, moving parts in the picture, but I see, I mean, I am an optimist by nature. I'm always trying to see the glass half full, but I wanted to share with you these positive signs in the right direction, even if I really agree with all the other speakers who just mentioned that is not as easy as it may sound, that we have to push all together in order to be able to quickly reach an agreement on space traffic management or coordination, because it's absolutely mandatory.
Okay. Sergio, could you add some comments and perspective?
Thank you, Joe. Simonetta has already addressed some of the things that I wanted to mention, so I would only add that it is important to have the work at the international level be done within the framework of the Committee on the Peaceful Use of Outer Space. This is the only body that deals with issues related to the peaceful use of outer space. And then within the committee's purview, there should be work that is done jointly, which means exchanging information, not meeting at the same time, between the scientific and technical subcommittee and the legal subcommittee, so that they do not work on two different tracks that never meet. There should be a feedback from one to the other. And that's all that I would add at this point.
So could we just see whether Adriano has some perspective on this issue, or also the idea of reutilization of debris in new ways in orbit? Adriano, are you there?
Yes, I'm here. Yes.
Please
So,
go ahead.
okay. No, just the small comment I made in the chat about possible commercial use of space debris, because they cost those material costed a lot to be launched in orbit. And now we think to spend more money to deorbit them, to bring them to burn in the atmosphere. A very more worth activity would be to start working to reuse those materials in order to build space infrastructure, to use them as orbital in situ resources. I believe that would be the real point where the space debris problem will be started to be solved, because it will be not only an expense, but it will be an investment to use those resources and get a new profit by them. That is a commercial spring that moves all human activities. And yes, of course, laws and the legal framework should be implemented absolutely, because there must be rules. And it is true that whatever you put in orbit, you have to think about, not just abandon it there. It is true, but there are two ways to take care of them. One is to destroy and lost, and the other one is to reuse. And I think what we are saying on Earth about circular economy, etc., should be also considered for space. The circular economy in space is at least worth as it is on Earth's surface.
Well, certainly Peter Martinez's organization, the Secure World Foundation, has done some studies as to how that might be done and the economics and so on. I know that Tanja Masson-Zwaan is on the next part of our panel, but I thought maybe she might have some perspectives on this issue in terms of orbital debris, space traffic management, and so on. So as a past president of the International Institute of Space Law, I would like to see if she could add to this discussion.
Thank you, Joe, and hello, everyone. Nice to be here. I believe that actually most of what has to be said on the topics of debris, space traffic management has been said. Perhaps I can add that at the International Astronautical Congress that took place just last week, the International Astronautical Federation and the International Academy of Astronautics and the International Institute of Space Law, which are the three organizations that came into being in the late 1950s, 60s, adopted a executive summary of a study that took place over several years to study all the various aspects of space traffic management. And so in a special session at the Congress, this executive summary was adopted. It was the result of many working groups and discussions and deliberations that I think underlines, is one of the examples that underlines the importance of these topics. And also I think it is quite remarkable that you see many, let's say, bottom-up initiatives also coming from industry itself, with initiatives like Net Zero Space or the Space Sustainability Ratings that were also mentioned earlier by Uwe. You see that on behalf of the stakeholders, there is a realization that sustainability is an urgent issue that has to be addressed. And so I think also that I'm quite optimistic about at least common standards being adopted as we move into the future.
As a member of that committee working with Professor Marie Bajah, I was impressed that this was not the usual platitudes, that there were some very specific ideas and concepts and I considered workable ideas to move forward. So I'm actually very hopeful that that process might be successful. So we have moved through a number of issues related to the threats from asteroids and comets. Comets are an even more difficult issue than asteroids. The issue of solar storms and coronal mass ejections, and now space debris. My one concern is the fact that the space agencies and most of the international discussions of this divide cosmic hazards up into parts and have different scientists and different groups working on this. I really do think that if we could move toward some sort of a space sustainability activity, it would make sense for the space agencies and for the international discussions to look at cosmic hazards more as a whole and how to prioritize these issues as we integrate them together. So that's just my personal comment. I would like to, at this point, go back to Kim to see if we have questions from the audience that we might want to address.
I need a couple more moments. Dr. Pelton, please continue this
Okay.
discussion.
Well, I did want to get back to Jakhou again as to thoughts about what we could do in terms of international organization and space debris and process, including this new joint initiative between the Academy, the Federation, and the IISL. I think that's certainly one very positive step. Ram, do you have further ideas?
Yes, thank you very much, Joe. I have a couple of points first before I get into the topics you have given me, the question of debris in moon orbit and on the moon and other points. The first thing is generally said that what we learn from history is that we learn nothing from history. And also what we do on Earth, we are or we will be doing in space. I don't think we will be behaving differently because we are the same species or the same DNA. What it means in the context of our term is that we have created debris on land, then we went to the oceans, we created debris there, we created in Earth orbit, and we are creating debris in the moon orbit and on the moon and other celestial bodies. So what I'm saying is it's very important to understand and that in a way somebody said it that population and pollution go hand in hand. I think that is a kind of old thinking or saying need to be assessed very carefully, that we kind of intelligent beings are not really that intelligent. We are killing our own house with all kind of things. So what it all means is what has been said is, with all other speakers, I agree with that. But one point is very strict. I'm sticking to the point which was made by Tommaso. I think we don't do things for the sake of doing good things. We're doing it, we are forced, when we are forced to do it, then we do it. That's very sad sort of story we have it. So voluntary guidelines, best practices, these are wonderful ideas, but they have to be put in a certain frame where people will be supposed to be, following that. If we do not have binding rule on people who drive when they're drunk, I think a number of people will be doing that kind of thing. So voluntary things are fantastic by people who believe in the welfare of others, even in self-interest. So one has to look at all kind of opportunities. The second point I like to see is really this, which Lucy said it very correctly, this is a global problem, needs global solution or global governance. National systems are very important with respect to the implementation of international binding rules, not standards. If you let countries see whatever they may follow or not follow, and that's what we have seen. The debris, space debris problem in Earth orbit, was settled in 2011. National Research Council said we have already reached the tipping point. And I think the things are not improving. And sadly, I don't think there will be that improvement even Earth orbit. Even few days ago, Dr. Lal from NASA said space, orbital debris is one of the greatest challenges of our era. So what is happening is that we are not doing enough. So we need to start thinking differently, maybe going back. There has to be binding laws, there the punishment is there. The binding laws at international level, which forces nations to take action. There has to be monitoring of the compliance with the laws, and these nations need to have a domestic laws. So again, as Tommaso said, the example, we have a very good example with ICAO. ICAO has a technical standards of the safety and security. The ICAO itself monitors who is following those standards. There's an element of naming and shaming those countries are doing. The second point here is that there's an element of being, if you have created the problem, why I have to suffer from that? The problem has been created by major space powers, and the new powers are saying, hey, why we need to? If you can create debris, why can't we create debris? Why we have to take your standards today? The question of equity, I think, is there. Now, new terms, whenever these things don't work, we come up with the new terms. And it is a bit strange to me, the responsible behavior of actors or nations. What does it mean responsible? The question is, who really set up this responsible behavior? It used to be, and still it is, legal or illegal. And then people think that way. I think what I'm saying, one has to understand, it is for everybody to understand space debris is a global problem. And that is not being realized. And as the more countries, those who are spacefaring nations, they have to realize that it is in their interest to solve the problems on that. Now, the last point I have, it is really, I consider prevention to be better than, prevention is better than cure. Now, we are still struggling with the debris in Earth orbit. Let's start trying to think about the moon orbit or the debris on the moon, so we can prevent these things. I have never seen, I didn't see any really serious effort being looked at that how much debris is being created and what should be done about it. We need more studies. Now, I understand, I'm not a scientist, but I understand the physical characteristics of the moon and the orbit surrounds are different from Earth. So we need to look at what does it really mean debris in moon orbit as well as on the moon. So one has to look. The example, another thing is, if you see the 1960s, early 1960s, there was a problem with respect to detonation of nuclear devices, weapons. So you come up with the world came up with the 1963 Partial Test Ban Treaty. It was started by few nations and everybody went on board. Perhaps it is, to me, the major space powers should also consider it is their obligation to keep space not only for themselves, for others. They should come up with a binding treaty with respect to debris in Earth orbit as well as in the moon orbit. So, and open for other countries. And actually they will be binding and then they will be monitoring. So I think it's a good idea to be a good person, but sometimes you've got to be forced to do certain things in that way. And no, I think the copious working group on space resources may think about the problem of debris and moon orbit. And I think that we need to little bit more. So my message is if you look at the major problems today the world is facing, the global problems, they are not being solved, in my view, mainly because there are unilateral solutions provided to that. Global problem needs global solutions. So this looks at the climate problem, you look at disarmament problem, we look at the human rights problem. All those global issues need to be global solution. So you need a global effort with respect to binding treaty or binding system, which has a monitoring. I have done some studies on that. Perhaps the question of commercial private companies can be brought into cleaning up the mess in the orbit, Earth orbit. But there are legal barriers to that. First barrier is all the launching state, the state of registry maintained its jurisdiction control. You simply cannot pick up anybody's satellite and remove it. So you need understanding of all countries involved in that. They allow their satellite, which have become defunct, to be removed. So that you need a law allowing these countries. So, and perhaps something, an international commercial institution could be put together where private sector is involved in the action, taking these things out under the global framework. So public policy and private action towards that. So that is, I think these are the things which are necessary.
Thank you very much, Ram. I think you make some interesting points in terms of, first of all, learning from the past history. A man named Don Kessler warned about orbital space debris in the 1980s, and no one took it seriously. Today, I and other people are saying, hey, we're now planning to put space stations around the moon and stuff on the moon, and we have no process to get rid of the debris afterwards. And also even ideas of putting communication systems around Mars, but how do we get rid of the debris afterwards? So we haven't learned from the past, but hopefully we can going forward.
Yeah,
so I do think
I have a comment.
Kim, are we ready for questions?
Yeah.
You have to unmute yourself.
Okay, now I have a comment.
Okay, go ahead.
What we have learned is that we have to listen to the scientists. And I have a big respect for space lawyers, but it's very important to know there are laws even above that. These are the law of astrodynamics. So Don Kessler, okay, as a scientist, made this prediction. So we have to listen to them, and we have to look at what are the measures we take as a society. In the case of the moon, what science tells us, and it's what I'm teaching to my class here, is that the moon has a very special class of orbit because it is going under the mutual perturbation of the Earth, the Sun, but also there are so-called mass concentration on the surface of the moon that make that all orbit around the moon are unstable. So they have a very short lifetime. So for instance, we lost Smart 1 after 1 year because we were out of fuel. All subsequent lunar orbital missions had to go to an impact. So we have, please lawyers, use this fact and incorporate in your thinking what you can learn from scientists, and the same way as scientists have to learn from lawyers. Now I think that a big challenge of traffic management for the moon is because these orbits are so unstable, they are very difficult to predict. And then if you want to operate a rendezvous to be effective, then we'll have a very complex timetable. We need to have some tool in order to be very efficient in the way we are going to explore the moon, to have access to various places on the lunar surface. And the other aspect is, of course, the way we are going to use resources on the surface of the moon, how we can maintain some areas which are common heritage from our history. So there are some foundations that are looking at that, how we can reserve some places on the moon where we can still study the science, in particular in some polar areas. We have some deposit of ice that can tell us about the history of water in the solar system, and then how we are going to exploit some of the resources, reuse them, develop a circular economy, or develop even a rocket from the moon. So there is a lot of work that is to be done between the scientists, the engineers, the lawyers, the deciders, the political world, and the public. But we don't have so much problem into risk of collision with lunar orbiters because these lunar orbiters are unstable.
Well, we have certainly heard many times the idea of a circular economy for space as well as a circular economy for Earth, and this is an important lesson. Before we go to questions, I would just like to indicate to all the speakers, if you have specific thoughts and ideas that you think should be included in the paper that we developed for this session, please send them to me at my email address. So Kim, do we have some questions?
We have one attendee who is very interested in hearing how cosmic hazards in particular and orbital debris can affect launch cost realities and the internet. I know that several speakers have touched on both. Is there anything else you would like to say on that subject?
Thank you, Kim. I am very grateful for this session, and I'm grateful for the way you moved from the near-Earth objects issue, which is real but small and is not a top international priority or shouldn't be. The debris issue and the EMP issue are very, very large policy issues. But my main comment there, these are hugely important issues. I hope we can connect to do justice to them in the future. They are more complicated than anything we could discuss in a brief session. But what we haven't discussed are two other issues, the huge internet issues and the launch cost issues. And if I had to pick a single area where I wish the space community could work together better internationally, it is exactly the launch cost opportunities, which are critical to the future economics of space, no matter what we do. And right now, if all we do is rely on the SLS and SpaceX, frankly, there is much better technology. And with international cooperation, there are opportunities to do much better in the economics of space, which cuts across everything else we're doing.
Paul, thank you very much. I would just open it up to panelists to respond to the future of space. My guess is Adriano would probably like to comment on that topic.
Mute. Okay. Yes, I think, thank you, Joe, for inviting me. I think the point on the cost of launch and I would say of all space missions is a very important point. And we are witnessing at least the first key milestone on this road to downsize the cost of space mission with the development of a fully reusable launch system that is the Starship by SpaceX, that we hope it can be tested, the first orbital launch, maybe in October, Elon Musk said it could happen. However, okay, let's hope it will be within this year. It would be already a good, fantastic thing. But the second key milestone, as Jeff Grayson already said in 2017, I think for the first time at the ISDC 2017, is to start producing fuel in space. That would downsize the cost to orbit very much and downsize the cost of any space mission, because if we don't have any more to take all the fuel from Earth, that's a big, heavy amount of materials, then let me say the space settlement or the civilian space development, as we call it at SRI, would be really starting, because the cost to bring one one person from Earth to orbit will be less than 1 million, and that it could be the threshold to really start working in space. And then the orbital debris will be boosted because we will have maybe factories, orbital factories, to recover and reprocess and repurpose debris and many other things, and the maintenance, orbital maintenance of satellites, and etc. Moving from one orbit to another orbit, and many services. So fueling in space is key that we should have in our mind, and to propose wherever we can in all where the decision makers are taking their decisions.
Well, I would just like to add the idea that we find often that the technological solutions and the technical innovations come first, and then it's only with hindsight that the institutional arrangements, the legal and regulatory processes are developed to respond to the problem. And that several times we have mentioned the importance of interdisciplinary studies and activities. At McGill University, there's been a number of efforts to do interdisciplinary studies of space to look at what are the technical problems, what are the technical solutions, but perhaps even most importantly, what are the institutional and legal solutions to cope with innovation. And always the legal solutions come last. And as we move faster and faster with our technology, this will be an ever greater problem. So
Dr.
please go ahead, Kim. Kim,
Yes,
please go ahead.
Dr. Camacha-Lara has a couple comments.
Okay, please. Sergio.
Thank you very much, Joe. I'd like to make a comment on the comments that were made by Paul Werbos. In particular, the one that relates to planetary defense. Planetary defense is not a small issue because the you mentioned in your introduction, a little bit later on, that the Tunguska asteroid was on the order of 30-some meters.
35 meters.
And destroyed an area the size of a metropolitan city. The distribution of sizes of the asteroids is inversely proportional to, rather the number, of asteroids is inversely proportional to the size, which means that of the smaller ones, we have a lot more. And in the range of 100, which is quite a bit bigger than that 35-meter asteroid, we have a very large number of which we have only found somewhere around 30%. So there is a big risk. The probability of an impact by a large asteroid is quite small, but the effects are devastating. And we have the technology both to look for them, and then in case one is coming to impact, to do something about it. So it is not a small issue, and this is why governments are investing large amounts of money in the search and in the development. SimPage is developing, planning missions to act in case there is an impact threat. And this planning is not just a study, it's not a 100-page study. It's actually the planning of the mission itself, which is being filed so that in case an asteroid with certain characteristics is coming towards Earth, then 2 or 3 years worth of work have already been done for different scenarios of impacts on water, on a city, on the ocean, or on the ocean away from land, or perhaps nuclear power centers. So this is an important issue that one needs to make the general public aware of, because it is the public that eventually finances the studies that are and the work that is being done by the governments. The taxpayers are the ones that that finance it, and they should be aware of why are we spending money for planetary defense.
Thank you, Sergio. Just to emphasize some of the points of that, we know, if you will, 35-meter asteroids are city killers, and that you think, well, the current standard is 140 meters, so that's 4 times smaller. Well, no, it's 4 cubed. It means that an asteroid that is 64 times smaller than the asteroids we're doing a systematic search for are city killers. And so the idea is we need better technology to detect much smaller and much more prolific, much more numerous asteroids that are out there. But also I would emphasize solar storm, a huge Carrington event solar storm could wipe out the global economy, that the collateral damage is 1 billion people might starve to death. So these are not small issues, and that the public, unfortunately, does not understand the degree and the nature of the threat. And people say, well, why hasn't this been a big problem before? Has the cosmic threat changed? And the answer is no. It's the world that has changed. Our dependence on infrastructure that has changed, and the global population has changed, and the size of cities have changed, and that we have not understood that we are more vulnerable to planetary threats than ever before. So with that, I think we need to close out. I need to thank all of the distinguished panelists from around the world. And Kim has something important to tell us.
So,
Kim.
Sorry, Joe, can I make a small comment? Is it on?
Well, we have just 2 or 3 minutes, but quickly, yes, please.
Very quickly. This is actually a lighter note, I must say. I think we heard Dr. Foing defending the scientists, and I must say, I fully agree with him. The tragedy of humanity is that we don't really believe in logic in general.
And
engineers also. I think, but we are not pointing the fingers to the real culprits here. You know, scientists and doctors are brilliant people. They have been telling us all those things, but we have been ignoring that, and that's why we are in a big problem. And I must defend my own profession, lawyers. The lawyers are really at the end simply because there's somebody in the middle, from science to they are the politicians. The politicians are the one who create the law. And you may not know, there's a known or unknown rule, what is called intentional ambiguity in the treaties. So they create these ambiguities in the treaties, and because they have to meet the expectations of their customers. And nowadays, most of them are private companies. So the private companies try to have some sort of ambiguity so they can make money out of that. So I'm not totally defending the lawyers, but I think we should not blame all the lawyers at the same time. There has to be policy discussions which are needed to make that. And that is what happened. That's what happens with respect to climate change. The scientists have been saying all these things. Dr. Kessler said it, you know, as Joe mentioned earlier, nobody pays attention to these things. People say, well, we'll worry about these things. So my point is, I agree with you with the the credit, but you and other you please deserve that, but please do not blame us to that extent.
Interdisciplinary.
Thank you very much. I have to go for my class. It was a wonderful participating. Thank you, Joe.
Okay, well, finally, just to thank our two conveners, Vid and Kim, you did a great job. My apologies to Timoteo, who for some reason was not able to connect from space in Africa, but we had an excellent discussion among a great number of panelists. And at this point, I would like to turn the chair over to Pascale, the president of the International Space University, who will have I know, interesting and enchanting and event-filled discussion of all the ways that space systems allow the UN 17 Sustainable Development Goals to be achieved. And I will let Pascale to introduce her distinguished panel, and we will listen to hear the exciting things that they can tell us about how space can help us with environment, with food and agriculture, and with rescue and space, education and health, and all the various ways it contributes to achieving those goals. So Pascale, over to you, and thanks all to the panel.
Dr. Ehrenfreund, your speakers are all muted, but visible. Please have a great session.
Thank you very much. Thank you very much, Joe, for organizing these sessions, and welcome to the second panel of this UN General Assembly Science Summit on the topic space systems and achievement of the UN Sustainable Development Goals for 2030. So we have a shorter panel, it's only in 1 hour, but our panel discussion will focus on the goals that have been set in the 17th Sustainable Development Goal areas, as well as specific ways that satellite systems that have been deployed can be used to achieve the key goals related to health, telemedicine, education, ocean, land, food or disaster management, and many other issues. I think what is very important to show also that space is really spilling over in many other economic sectors and is playing a very important role in our daily life. And so we are gonna discuss many different topics, because we have a lot of experts here which are specialized on the topic. And in this 1 hour time frame, each of them will give a short introduction, and then we will actually move on to questions. So I want just to briefly introduce my stellar panel. This is Fiammetta Diani. She's currently head of markets, downstream and innovation at the European Union Agency for the Space Program, EUSPA, and she's responsible for developing the market and innovative applications of space data while fostering competitiveness of the space downstream industry, SMEs, and also startups. Welcome, Fiammetta. And then we have Tanja Masson Zwaan. She is Assistant Professor and Deputy Director of the International Institute of Air and Space Law at Leiden University in the Netherlands. She is President Emerita of the International Institute of Space Law, and she's also the co-founder and member of the Hague Space Resources Governance Working Group. Welcome, Tanja. Then we have Scott Madry. Dr. Scott Madry is Professor Emeritus of the International Space University and was a longtime member on the faculty. He's currently a Research Associate Professor of Archaeology at the University of North Carolina at Chapel Hill, and he specializes in the applications of geomatics technologies for environmental and cultural research. Hello, Scott. And then we have Su-Yin. Dr. Su-Yin is a senior lecturer in the geomatics program, teaching fellow of the Faculty of Environment and director of the Applied Geomatics Research Laboratory at the University of Waterloo, Canada, and she's a global faculty member of the International Space University.
and also working in the academic council. And hello, Su-Yin. And then we have, last but not least, Kris Lehnhardt. He's the element scientist for exploration medical capability at the NASA Johnson Space Center. And he's also the senior faculty with the Baylor College of Medicine in the Center of Space Medicine and Department of Emergency Medicine. So he is board certified in emergency medicine in both Canada and the US. And he works clinically in the emergency department at the Ben Taub Hospital in Houston. Welcome, Kris. This shows you also that we have really a very diverse panel which can address these many, many different applications of space data. And I'm going to start now to ask all the participants to give a short 3 to 4 minute statement about the expertise and vision towards the topic space system and achievement of the UN Sustainable Development Goals for 2030. And I will ask first Fiammetta. Thank you.
Thank you. Thank you, Pascale. I would like to give you the vision from the point of view of the European Space Program. So my agency, EUSPA, is taking care of the new EU Space Program that we have in Europe. And maybe you don't know, but EU is one of the major investors in global space today. And we have 3 different flagship programs. Let me quote a few of them just to then enter in the topic. So Galileo, the worldwide navigation system, all made in Europe, but serving the full world with the 3 billion users today. We have Copernicus, that is our Earth observation flagship, providing already today a lot of information on the climate change, on how we use our land, our sea. And this is actually the #1 Earth observation data provider in the world. And also we are venturing in secure connectivity with our first leg that will be is called GovSatcom and will serve Europe. And so also the secure communication will be added to the portfolio. So based on that, we do believe that there are many of the systems that can or are already contributing to the SDG. And to enter in the subject, we joined forces with UNOSA, and already some years ago, we made a study that is still very actual, I would say, in which we went to see how EGNSS, so our navigation system, and Copernicus can contribute to the SDG. And we found out, we used practical examples, real projects, real applications that were in the field. And we found out that at least 40% of the associated indicators to the SDG receive benefits from our system, especially when they're used together. So when we use together the knowledge of what is happening with precise location. And so we can also act and not just study what is happening. So example are, for example, all the natural disaster prevention and mitigation for SDG 1, or for SDG 2, zero hunger, for example, the crop productivity optimization that we can use using our images of the livestock management optimization. But also in SDG 11, the sustainable cities and community, the urban planning, the infrastructure monitoring, and their quality monitoring. So there are many examples that that we bring on the table in this study. And we are now going a step further, and we are analyzing how our space system can contribute to the new challenge we have in front of us, so the 8 billion population, and how they can help for a smoother transition. And there we analyze 7 challenges, including, for example, energy or food security and water management. And we will come up with a study soon, so you will have the possibility also to share with the community. And just to conclude, what I think it's the 2 key factors to better contribution of our space system to the sustainable goals. I would say, first of all, to think space in synergy. So it's not one single system or one single technology. They have to be used together to produce real end-to-end solution in the field. And the second factor is for me to put the users at the center. That is a bit what we are trying to do in Europe. So for example, next week, we will have our user consultation platform. We put together our user, we try to understand the needs and we try to use it really to evolve our services and system to better cope with the challenges we have in front. And we have plenty of examples I will maybe develop later on this. So thanks.
Thank you very much, Fiammetta. I think it's important that people which are not so familiar with space data realize how much they can contribute, and that they actually contribute to each of the Sustainable Development Goals when we are going to detail, and I'm sure we will cover a lot in this session. Thank you very much, and I come now to Tanja Masson-Zwaan and ask her for her introductory statement. Thank you.
Thank you, Pascale, and hello, everybody, and thank you for having me on this panel. What I would like to do in my brief statement is to perhaps give a timeline of what the involvement, of apologies, of UN and space can be for the Sustainable Development Goals. So it's clear that although the economy has grown a lot and we have seen a lot of technological progress in many decades, there are still many societal challenges that have to be overcome. And so in 2015, the UN developed the 2030 Agenda for Sustainable Development, and that consisted of the 17 SDGs with as many as 169 associated specific targets. And that came into force in 2016. And so they include what Fiammetta already referred to: no poverty, zero hunger, reduced inequalities, and I'm sure that you are aware of those. So it's clear that the main space applications, namely Earth observation, telecommunication by satellite, and satellite navigation, can play a role in actually most of the, if not all of the Sustainable Development Goals. And I invite you to have a look at the website of the UN Office for Outer Space Affairs, which contains a very interesting overview. You can link to each of the SDG and then see what space can do. So only two examples, of course, are climate change and disaster management, but there are many more. So then what happened in 2020, we celebrated the 75th anniversary of the United Nations, and the Secretary General was asked by the member state to prepare a report with recommendations to advance what is called our common agenda to respond to all these remaining challenges that we have. And so that resulted in a report, the Our Common Agenda report, which was presented to the UN General Assembly in 2021 and consisted of 12 commitments. And they include protecting the planet, leaving no one behind, build trust, boost partnerships, and so on. And one of them is to promote peace and to prevent conflicts. And in that commitment, it was recognized that peaceful, secure, and sustainable use of outer space was an important element, including through multi-stakeholder dialogue on outer space. So that report really looks at the next 25 years. So if you like, it is an outlook to the 100th anniversary of the United Nations, and it presents the vision of the Secretary General on global cooperation and effective multilateralism. And a long process was had taken place then, involving a multitude of stakeholders, including thought leaders, member states, young people, civil society, parliamentarians, think tanks, you name it. So that common agenda then includes a section on peaceful, secure, and sustainable use of outer space. And there in those paragraphs in that agenda, it is recognized that space systems are vital for understanding global problems such as the implementation of the SDG and climate action. It also recognizes the role of the private sector. I think that is also important, and also the risk these challenges pose to security, safety, and sustainability. So also then the common agenda recognizes the adoption of the long-term sustainability guidelines in 2019, which shows that progress in governance is not impossible. It may take some time and gaps will remain, but in the end, it recognizes that a combination of binding and non-binding norms will help us to go forward. And mentioning space traffic management and weaponization are a few examples. So what is then the expected outcome is that an international instrument on the prevention of an arms race in outer space should evolve, should emerge. Guidelines on active debris removal, we heard a lot about that in the previous session, as well as common principles for governance of space activities and space traffic coordination, again a topic that was also mentioned in the previous session. Looking into the future, to conclude, we will have an exciting joint panel of the fourth and fifth committees of the General Assembly next month to address possible challenges to security and sustainability. And in December, there will be the 4th World Space Forum, and there it will be a contribution to the outer space dialogue under our common agenda. So there, the United Nations Office for Outer Space Affairs will continue to discuss the contribution of space to SDGs and climate change, disaster management, and so on. So I will leave it for that to that for now, Pascale. Thank you.
Thank you very much, Tanja, and thank you very much for this comprehensive overview. I think in particular also for students, that is really, really helpful. And I come now to Scott Madry. Would you give your introductory comments?
Yes, hello everyone.
Yeah, here you are, yes, good.
Yes, I'm here. Thank you, Pascale, and thank you for the opportunity to participate in this. You know, we just spent an hour and a half hearing about the many potential threats that we have from outside our planet. But the fact is that every day around the world, we have natural and human-caused disasters, which directly impact millions of people. And in the context of the SDGs, we have to keep in mind that whenever people suffer disasters, as in the example of the terrible floods we're seeing in Pakistan, and there are many other fires, it happens all over the world every day. All of our progress in the SDGs vanishes. Whenever we have major disasters, people are focusing on simply trying to survive, simply trying to find food and shelter. The infrastructures are destroyed. And so our ability to respond to and plan for and adequately affect responses to disasters is absolutely critical to every one of the SDGs. And the good news is that we have made real progress. For the past 15 years, part of my career, part of my work has been living at the intersection between space technologies, remote sensing, telecom, navigation, GIS, and the disaster management community. Now, I've responded to many disasters in the United States and around the world, and we've worked with many organizations, and we've made real progress in trying to do a better job of integrating the technologies that we have. And the UN Spider program is an excellent example of this, facilitates the use of space-based technologies under the auspices of the UN Office of Outer Space Affairs. And of course, we have the International Disaster Charter, which has been enormously successful. We've had over 770 activations of the charter, providing satellite remote sensing and other geospatial data. Right now, we have over 270 satellites that we can draw from 17 different countries to get this data into the hands of people who need it. We also have the Digital Humanitarian Network, where all of the various different NGOs who are involved in this are also playing an important role. So we've made a lot of progress. And back in 2015, I wrote a book called Space Systems for Disaster Warning, Response, and Recovery. And this book was specifically written, the first half of it talks about what the space technologies are and who we are as a space community. The other half of it is about the emergency management community and who these people are and what they need. And frankly, we've had some difficulty in trying to find ways where we can adequately push the technology that we have into their hands, because ultimately time is the enemy, time is the issue. In all of these disasters, we literally have days to get the right information into the right people's hands to try to effect an effective response to save lives and infrastructure. And so we have a lot of work still to do, but we made tremendous progress, and I look forward to talking a little bit more about that later.
Thank you very much, Scott. I'm sure we will have to talk later on about the Charter of Major Disasters and how that works or how that could be improved. Thank you. And now I give the word to Su-Yin and for her introduction.
Hey, thank you, Pascale. Hello, everyone, and thank you, Pascale, for the invitation to participate in the session. Apologies, I'm recovering from a cold, so please excuse my raspy voice, but I hope everyone can still hear me.
We all do, we all do.
Thank you. Yes, so as you heard from the introduction, I am actually an environmental scientist by training. So the Sustainable Development Goals are fundamental to my everyday daily work, teaching and research. And most of my projects, I'm a big user of space data, as we heard before. Perhaps unique from the other panelists, the focus of my work on environmental studies touches on practically every single one of the 17 SDG goals. Some examples of this wide spectrum of work that utilizes space data, including Earth observation, telecom, navigation, includes current projects such as involving Wellbeing Waterloo, which is locally here exploring SDGs 3, 4, and 10 on reducing inequality to good health and quality education, especially for youth and children. In Toronto, which is the largest city in Canada, we're exploring using smart sensors and spatial data for tackling SDG 16 on crime and justice. Our lab is focusing on sustainable development goals in the Caribbean small island states, which is relevant to SDGs 13, 14, 15 on climate action, oceans, and land ecology. And last but not least, in the School of Urban Planning here, I'm teaching one of the first courses on smart cities, which is instantly right after this panel event, where we're focusing on using technologies for tackling SDGs 7, 8, and 11, which are related to sustainable cities, communities, economy, and energy. So with this diverse portfolio, you might wonder, what is the underlying theme that's driving all of this work? And from my perspective, it's really an interest in adopting technologies for developing solutions to complex problems. And these are increasingly pulling from space-based technologies for delivering sustainable, more efficient, as well as lower cost solutions for enhancing quality of life here on Earth. So space technologies are helping us to solve these sustainability challenges that have different dimensions: economic, social, and environmental. We heard from the previous session just now that we often adopt a systems thinking approach for trying to solve space engineering problems, such as how to build a rocket to go to the moon, or how to design a spacecraft. And in the previous session, we heard a little bit of debate and some discussion about listening to the engineers. I see Bernard is smiling right now. And however, human society and environment, when you think about it, we are also a system of subsystems. And each of those subsystems of human society or the environment are, number one, highly complex. And number two, all subsystems are linked together and affect one another. And a third, that there are technological fixes that can help us to explore and better understand the problems as well as potential solutions. Unfortunately, our subsystems here for society and environment often work as silos when trying to solve these complex problems. But the benefit of the SDG framework is that it offers this advantage of highlighting links and encouraging our systems and subsystems to ultimately work together. So last, I'd like to just end with a comment/open question. We're in this day and age where space technologies such as satellites, location-based devices, lots of sensors all around us are producing an immense amount of data. But how do we utilize this data to make better decisions for the future? We've reached the stage of big unstructured data, but how do we turn this into meaningful information that's useful to society? So the challenges now, I think, aren't exactly engineering or technological barriers, but how do we actually analyze and integrate the data we do have and connect them with solutions for reaching our SDG goals? So thanks again for having me in the session and looking forward to the discussion.
Thank you very much, Su-Yin. That ties very much what also Fiammetta said, that you actually need the users. And you need really to connect, and you need to have business models, and you have to see how you can actually provide the data so that the users can also do something with it and apply it. Thank you very much. And I'm giving the word now to Kris Lehnhardt. Kris?
Good morning to you all.
There you are. Thank you.
Yes. Good morning from Houston, Texas. First of all, I'd like to thank Dr. Ehrenfreund and the organizers of this session for the invitation to speak here today about space and its impact on telemedicine. As a physician who has been using telemedicine capabilities to care for people all over the world who are living and working in austere and remote environments, I can tell you firsthand that space and telemedicine are inextricably linked. Since the beginning of human spaceflight, telemedicine has been the primary means by which space agencies around the world have provided for the health and well-being of their astronauts, cosmonauts, and taikonauts. The telemedicine capabilities used in space have been vastly expanded from the early human spaceflights to where we find ourselves today. Now we are collecting, analyzing, and acting upon significant amounts of real-time health and performance data, which has had direct, tangible benefits for all humans who fly in space. In fact, using these telemedicine approaches to human spaceflight on the International Space Station, there has been no need for an evacuation from the space station for any sick or injured crew member in over 20 years. These advanced telemedicine capabilities that we use in spaceflight, combined with the use of extensive space assets like communications and navigation satellite systems, have also led to a revolution on how we use telemedicine here today on Earth. Now, almost everywhere on the planet, with minimal resources and training, telemedicine support can be provided to people in need in order to promote good health and well-being, which is directly related to the UN Sustainable Development Goal number 3. This has enabled healthcare to be continually decentralized, away from big cities and big hospitals to remote and isolated communities and populations, moving medical capabilities and decision-making to where it is needed most, where the patient is. Every day, as more advanced space assets come online and space medicine practitioners continue to develop new telemedicine capabilities for use in spaceflight, we are improving the health and well-being of all humanity, both on Earth and beyond. I'd like to thank you all for your attention to this important topic, and I look forward to answering your questions later in the session.
Thank you very much, Kris. And this is again a completely different angle, and you know, how we actually can use space data and connections. So I want to thank you very much to all of the distinguished panel members about your introductory statement, because that shows also you're coming from different regions, and what is all actually what we can all improve with space data. And I want to go a little bit more into some discussion and some questions. The first one I want to ask to Scott, because there are hurricanes approaching. We are in alarm everywhere all over the world. And so how can space technologies and you know, our access to space make a difference in the planning and the response to disasters around the world? And what does the Charter of Major Disasters, what role does it play?
Yes, and we do use it every day. The satellite imagery, the geo imagery, tracking these major storms. Right now in my home in North Carolina, we're planning for an approaching hurricane. I'll be working with the American Red Cross here later this afternoon in preparing for that. So we do use space technology every day, imagery, but we still have a lot of work to do, and there's a lot that we could do better. The problem is that the scale and severity of disasters continues to increase. And so we have to continue to do a better job. The availability of daily global imagery, high-res imagery from organizations like Planet is enormous and gives us the kind of time frame access that we require. As I mentioned before, time is the enemy. Kris knows exactly what I mean, that golden hour. We have to get the right information in the right format into the right hands in time to make a difference. And a day late doesn't cut it in disaster management. And so we have to continually improve not only the technology push aspect of this, but there really is a cultural gap. I'm an anthropologist by training, and there's a gap between who we are as a space community, the tech community. We're constantly wanting to push our toys out into other fields, but the emergency management community is a very different world. They come from a very different background, and they have very specific certain needs that they require. And so we have a lot of work to do in terms of continuing to improve our ability to put the right information into the right hands in time to make a difference. But we're constantly working on this issues. We have a lot of people. We're doing meetings with our emergency management community partners, and we continue to improve the process.
Thank you very much, Scott. So this seems we are still in a learning process, and the fact that disasters are getting more abundant doesn't help. Yeah, when I understood your and it is I think a big problem of logistics. And I want to hand over now to Fiammetta and talk a little about innovation and so what's the role of innovation to foster the contribution of space for the sustainable development goals, and how do you actually work and foster innovation at USPA?
Yes, so thanks for the question. Indeed, we were mentioning before that we have a lot of data coming from our satellites, but it's not always so obvious that this data translate in a user's application that can be used really on daily life to make our sustainable development goals even more reachable. So I think innovation played an important role here because it transformed this raw data in something that is in the field. And the way we interpret innovation is that it's not innovation for rocket scientists, it's innovation for people that are really in the field, for also SME. And we have a program specifically for startups. We have students here, so maybe this is interesting. We have a new program, it's called Cassini, to foster the entrepreneurship using space, using space data in particular. And why this is good for our SDG? I think that innovation, first of all, bring new forces in the Space Club, because often we have quite a restricted circle, for example, of experts in Earth observation. I think that if we really want to arrive to the point, we need to enlarge this circle. So innovation, first of all, permit us to have new forces, young entrepreneurs, young innovators entering in it, and also permit to experiment, to go a bit farther than what we would do if we don't have this community or this innovation involved. For example, recently we had a call for a Green Deal, so where we asked to put together GNSS and Copernicus, and it was the most attended call we had since a lot of time. We had a lot of ideas that go, for example, in the energy efficiency using Earth observation and navigation together, but also, for example, in combining biodiversity and agriculture. So in doing with the accurate navigation and with the right images, a precise agriculture that will preserve the biodiversity. Or we saw also this summer the heat waves that and the drought. So there, Copernicus, for example, was able to understand in major cities in Europe what was happening, and the urban heat island, as we call them. and so to give the tools to prevent it next year. And I think that innovation play essential role to really arrive to the right solutions.
Thank you very much, Fiammetta. And since we had a United Nations panel here at the Global Summit, I think I have a question for Su-Yin. Does addressing the Sustainable Development Goal really require global equality? Would only spacefaring nations have an unfair technology advantage? How do we actually make sure that we can serve, the global community?
Right. Yeah, thanks very much, Pascale. Yeah, I think that's quite a complex question with many aspects to a very interdisciplinary question. I think that there's no denying that the financial aspect is a key part for implementation of the SDGs. I think that there's been estimates from the UN that additional global investments of about 5 to 7 trillion per year is required up to 2030 in order to meet the SDG targets. And so I think that there's also a clear commitment that richer countries, such as spacefaring nations, need to support the lesser developed countries to achieving the SDGs. I think that there were plans, there were promises from developed countries to pledge a percentage of their GDP, like 0.7% of their GDP, but not everyone has really followed up with those promises. So I think a lot of this comes down to a governance and management issue, maybe a policy issue too, that Tanja might be able to elaborate on. But I think finances is one thing, but knowledge and technology transfer is another. And I think a really big challenge that we have to think about for developing countries is the lack of available proper data for assessing indicators of the SDGs. So I think it's essential that we have data that not only tries to propose solutions for the SDGs, but also indicators of how we're performing. Like, are we doing well? Are we on track for achieving these targets for 2030? So there's definitely a need for improved international cooperation, which ironically is an SDG in itself. So SDG 17 is all about international cooperation. And so I think there's a recognition for this, but similar to what we heard in the previous session just now, I think that Jakhou was saying earlier that we only do things when we have to, when we're forced to, when there's a sense of urgency, and that prevention is better than cure. And that actually had me thinking about that there is already really exceptional data sharing agreements available, such as the World Meteorological Organization, the WMO, is one of the best examples of data sharing between governments. And they have the unified data policy that reaffirms commitment for free and unrestricted exchange of observation data from all parts of the world, quite often in real time or near real time. This is how we know about these hurricanes that are approaching us right now, that are making landfall. So I think that there are these models that exist, but again, is that sense of urgency that we see disaster management, the weather forecasts, prediction, and so on is highly urgent, but we have to recognize that climate change and these impacts on these various SDG subsystems that we're talking about also require that urgent available data. Thanks very much.
Okay, thank you very much. I think it is an important aspect because a lot of the difficult things actually happen, in this the underdeveloped world, and we have to find a possibility to reach global equality. So I have, before we go into back to really UN issues, I wanted to ask Kris Lehnhardt. You explained very well, that telemedicine is really related to space, but we have also a lot of students here and other people which can probably not understand. So how do actually space systems work together to enable telemedicine care around the world? I think this is something which is not quite clear for anybody, and I think it's important subject to know.
Thank you, Pascale. It's a difficult question to answer. So I'm, as a good teacher, I'm going to try to give you an example so that it'll help the students to understand. And so this is a personal example where I have been involved in telemedicine care in the past. And in this case, we were providing medical care to a mine worker who was in a remote location on the African continent, who had an emergency related to diabetes or high blood sugar. Our ability to care for that person in that very remote and isolated place was only possible because of the space assets that we had access to. It was essential that we have two-way communication in the form of both text and audio and video. We had to have communication that had minimal delays or dropouts. We had to be able to transmit medical procedure information to the people in the field, so they would be able to perform medical procedures as needed because they couldn't reach medical care immediately. We then also had to know exactly where they were in the world so that we could then locate the nearest medical facility with the right capabilities to manage that care. In order to do that, we had to be able to analyze environmental and weather data so we would understand the ground truth of the situation that they were in, and then arrange for the appropriate and timely evacuation of that person. And while they were being evacuated, we had to be able to monitor their condition and update their treatment plans en route because it took them many hours to reach medical care. All of these factors, all of these elements of their care, every one of those along the way had an impact on it related to space, whether it was an innovation from telemedicine that we used in space, whether it was space-based assets that allowed us to provide that care and those different elements that were needed in order to take care of that patient. All of it was interconnected. And so the innovations that we developed for spaceflight have ground uses, and the space assets that we develop for ground uses have many different uses, including ones that may be seen as unconventional, like telemedicine. And so I would suggest that in order for all of these space systems to work together to enable telemedical care around the world, they need to be interdisciplinary. They need to be integrating and interfacing all of these systems. And we need to have an end-to-end concept of operations of how we're going to use space to improve telemedicine so that we can promote health and well-being around the world. Thank you.
Thank you. That was a really great statement. Also, I'm coming now to Tanja because we talked about so many different aspects, and you are the expert about, or the overview, and wanted to ask you what areas or activities should you and OSA prioritize to ensure that all these space-based solution can be also really efficiently applied for achieving the SDGs. You have seen that you had many discussions that things need really to be improved, and it needs more cooperation, it needs more global equality. Could you elaborate on that?
Yeah, thank you, Pascale. That's not an easy question to solve, but indeed, we must probably make priorities in what we can address, at least what the role of the UN Office for Outer Space Affairs could be as an actor, as the Secretariat of UN COPOS, and as also the Secretariat of the International Committee on GNSS and so on, as also involved with the International Asteroid Warning Network and all these things, and also with very limited staff and budget as well. So clearly it will be necessary to set priorities. Personally, I would say that issues of sustainability and security in the sense of arms control and avoiding a weaponization and long-term sustainability preservation are at the core of being able to do anything further in outer space. And if you look at the Space 2030 agenda that was adopted, you see that the objectives have been set out in 4 pillars: economic, societal, accessibility, and diplomacy. And along those 4 pillars, there can be several activities that can be taking place. How to implement that is to make partnerships, to not only rely on the UN network itself, but to use also the member states, to use all those other different stakeholders, such as non-governmental organizations, but also private industry, and also all the existing tools that exist already within the UN space framework, if you like to call it that. The reference was made to the Disaster Charter, but there's also the UN Spider platform inside the UN. There are various regional centers that can be of great help in capacity building in both legal or practical aspects of space applications. There are initiatives such as Space for Women or Access to Space for All or Space for Youth, you name it. There are so many going on. And I think that all of these initiatives and all of these potential partnerships should be used so that we really use all the tools that we have to realize those objectives of that ultimately will help realize the Sustainable Development Goals, the Paris Climate Framework, and the Disaster Management Framework, and so on. Not perhaps a very concrete answer, but I hope to indicate a few avenues of urgent action.
No, I think that this was interesting. Honestly, I'm on many panels like many of you, but I find it really great. There are certain things I don't know, and it's really great to learn, and how you speak all very clear. So I'm gonna open it to questions, questions which come over the chat. And there's one question: do we need new satellites? Oops, where is it? Do we need new? Oh, sorry, it just disappeared now. Here I have it. Do we need new satellites and space technologies to advance effort for disaster relief? Who wants to take this question? Okay, Scott.
You know, we always want more toys. We always want more satellites. And yes, of course, we want better access to more tools. But honestly, we have daily coverage of the world today. I am more interested personally right now in how we can develop better open source tools to get the information into the hands of local people. I work a lot in Africa, at least up until COVID. I was teaching every year in Cape Town down at the University of Cape Town, and you know the needs and requirements and capabilities on the African continent are so different from what we have in North America and Western Europe. And so I'm working a lot right now in developing better open source tools so we can put free, low cost, easy to use tools into the hands of people across the globe. Many of the tools that we have to do the geographic information systems and the image processing are proprietary and very expensive, hard to use, and only run in English language. And so I'm working a lot with open source tools like the QGIS software. We've developed a plugin for QGIS, which is a disaster planning and response tool called InnoSafe. And the great thing is it's free, it's easy to use, and it runs in over 40 languages. And so I think I'd love to have more satellites and more data, but ultimately in the end, what we need to do is get this data into the hands of people all across the planet, and developing open source tools that run in many languages, I think is even more important right now than getting more platforms in space.
Thank you very much, Scott. I have one question, which is a difficult one, also from EPFL. Are there some space missions and development that have negative effects on the Sustainable Development Goals? Is there anybody who wants to take this question?
That's interesting.
That's interesting.
There are, of course, certain planned future commercial missions for which you might wonder whether they are in line with keeping space accessible for all. And one extreme example, perhaps, but it's a real one, is a mission to send ashes of people or animals, pets, to outer space. I mean, this is being done in little lipstick-sized capsules, and that can, of course, create a risk of collision. It will increase the congestion in low Earth orbit, or even if you would send it to celestial bodies, they would stay there forever, and they could affect the environment and things like that. So certainly there is also the example of the huge constellations which affect astronomy, where you could say this affects also the accessibility of humanity to knowledge about our universe. How should we balance all those interests? That is, I think, also an important question, where legal aspects will come into play, where you see the responsibilities of states to authorize and supervise the activities of private entities, which are often the actors of these, not always perhaps completely, if you like, ethical uses of outer space, even though in principle use of outer space is free. So it is not by definition prohibited, of course, but you could ask some questions about the desirability of such activities.
Thank you very much, Tanja, for saving us. And there is another question, which is probably for Su-Yin, or why are we still not able to detect or react in time for fires with devastating effects like in California or Europe?
Yes, I think that's an excellent question. I think that a lot of these disasters that we see are very complex in nature. There are many drivers that determine when a wildfire might happen. There are different causes, both natural as well as anthropogenic or human caused. So I think that is quite challenging to predict where fires occur. But with space data, I think one of the benefits is that we have more predictive capability. We've seen just before COVID, all the wildfires that broke out in Australia. And I remember that NASA put together a really great application at that time that was really showing real-time meteorological data of looking at lightning strikes, for example, that were detected from satellite imagery. Also, we can predict where fires might occur based on vegetation type, terrain, and different types of factors. So it might not be necessarily direct sensing of fires necessarily, but we can try to predict where the likelihood of fires are. And that's where data really becomes useful, is for modeling, prediction, and forecasting. So I think that there are, some potential for that. But I think that there's also in California, Europe, and other areas. We saw recently in Portugal in summer that there were a lot of fires occurring there. That sometimes with these really complex types of natural phenomena, that it's also very human driven, and impact is also defined by where people are living, where people are residing, what kind of activities are happening in an area. So that's something else to think about, is also where areas are most potentially impacted.
Can I maybe, Pascale, add something about this?
Yes, please, go ahead.
Yes, so I think, so I will link it also with, do we have enough satellites or do we need additional ones? So I think in principle, we do have a lot of satellites. And for example, at USPA, we invest a lot and we claim also that the private sector has to invest a lot in the so-called downstream. So using this data, because we invested a lot in the infrastructure, it's now time to invest in the downstream. However, I think there is still room to improve our system. And for example, in Galileo, we are studying a new service, it's called Early Warning Service, that will permit, for example, to inform the people that are at risk in a certain area for a fire or for a flood, for evacuation or for other alert. So this link me also to why we're still not able to use at the full capacity our system in the fires or in other disaster. I think there is also the link to be made. So it's not only to have the images, but really to put them in the operation and in the people culture so that they can be really used. For example, in Europe, we can activate a civil protection mechanism and call the Canadair from another country to intervene, sending them the Copernicus images. So I think this kind of things has to be activated and improved more.
Thank you very much, Fiammetta and Su-Yin. I think these are really important topics. There is a specific question for Kris Lehnhardt. What space provided services do you need to advance telehealth further?
That is a great question. I appreciate it. Thank you. I want to build a little bit more on some of the things that Scott and Su-Yin were discussing when talking about the need for having data and information that we can use in a timely manner. And so it has to be as actionable as possible. And so in many cases, I would say from a telehealth perspective, it's unclear to me. I'm not certain that we truly need more space-based assets at the moment to optimize telehealth. I think what we have to do is find ways to aggregate and interface those systems and that data together. And so right now, the example that I gave you, we were accessing different systems for navigation and different systems for communications and different systems for Earth observation and remote sensing. And the ability to take all of that information, to bring it together, to analyze it and make it as actionable as possible, as quickly as possible, is an area that needs further work. And so we have a large amount of assets, we have a large amount of data, and our ability to integrate that data and use it effectively is something that I think is an area that needs additional work. And the space assets enable us to do that. But adding more assets, frankly, just adds more data. And we need to figure out ways to truly use the data that we have access to right now today.
Thank you very much, Kris. There's one last question, and then I'm going to give you the possibility to make a 1 minute, I would say conclusion about also what you heard from your colleagues. But there's one more question, which is, do you think that women have an important place at work because of their contribution to the development of the SDGs? Or are we still lacking, an equal footing? If nobody wants directly to answer it, I can answer it. So I just want to say that we actually really, there are many studies now that diversity and gender equality is really improving the productivity of in many different companies. And we see also that even the revenues of companies are raising when we have gender equality or also different diversity, different sets of perspectives. So there are many, many studies which are there. We are not yet there. When you look at for instance, the gender gap, which was published. I always know Iceland is always on the top. Yeah? They are the best, but there is still a lot to do. And I remember that I think it's the World Economic Forum, which is making this yearly book for the gender gap. And it says sometimes, which frightens me, that we need some, decades or so in order to go to the correct numbers. So honestly, it's an important question because we know it will improve our standard and it will certainly then equally translate to helping finding solutions for sustainable development goals. But I think in some nations, there's still a lot of work to be done. I hope that was satisfactory, and I would like, we have about 3-4 minutes left. I don't know how long my speakers of my distinguished panels can probably make 2-3 minutes more. And also the class of EPFL, I think, is closing at 6. So I wanted to give everybody an opportunity for giving a concluding statement, short if possible. And maybe I may ask first Fiammetta.
Yes, so thanks, Pascale, for this nice opportunity. I really thank Scott and Tanja for the work they're doing, and also Su and Kris for the very concrete examples they brought on the table. It was a learning opportunity for me as well. If I have to conclude, I would say that the most important things for space to really contribute to SDG is to put the user at the center and to enable them to use our space technologies and system as far as possible. And this innovation bring a clear role in this.
Thank you very much, Fiammetta. Tanja?
Thank you, Pascale. I think it's very useful to have a forum like this where we try to not convince, but at least explain to a wide audience how important space is for our everyday lives. And I can only underline what elements that have come up during this hour-long discussion: the relevance of accessibility to data, the importance of capacity building, the importance of multilateralism, of doing things together, not on islands, and also the importance of involving really all stakeholders that have an interest, and we have to do this together. Thanks.
Thank you, Tanja. Scott?
Well, thank you very much for the opportunity to participate today. It's been very interesting, always is. The one thing I would like to say at the end is that we live in a time of extraordinary technological development and change. The speed of the new technologies and all the aspects of space, telemedicine, communications, navigation, it's spinning so fast. And we have to continue to work very hard on making sure that what we do is relevant to the end users, and particularly across the globe in places like Africa and Asia, where what we do is, it's very difficult to fit into the reality of the work that they do every day. So finding ways to make sure that we can be relevant and that we're not just pushing new toys, we're giving them actual capabilities that they can use in the field. We're preparing for our first hurricane of the season here in North Carolina, and I can tell you during an event is the worst time to introduce new technologies. They have to have a playbook that they're ready to go with, and it's the worst time to show up with a new toy and say, "Hi, can you download this new software?" And I look at this amazing thing. No, that's the worst time. We need to do this months and months before the events come. So we have to continue to find ways not only of developing new capabilities, but making sure that what we do can be put into relevant capabilities in time, so that when the hurricanes come, they've already trained, they've already practiced, and they can put those tools to work.
Thank you very much, Scott. Su-Yin.
And similar to others, thank you, Pascale, and the organizers of the session for organizing the session and for the invitation to participate. I just want to end on kind of two notes. One is food for thought, and the second is a concluding comment. The food for thought is that I think for the SDGs, some are inevitably more technology oriented than others. So namely, we've seen like SDGs 2, 3, 9, hunger, health, industry, innovation, that tend to be more prone for technology type of solutions, but there are also SDGs that are lesser supported by technology, and what we've seen, just some food for thought, is 5, 10, and 16, which are related to gender equality, reducing inequalities, and peace and justice. So that relates really well to Amparo's previous question about gender equality, that different perspectives are needed, and that's where the role of diversity comes in for innovation and developing better solutions. My comment is that I think space is an important instrument that contributes to reaching the 2030 agenda for SDGs, but is not a fix-all solution. by any means. I think it's only one of the sort of toolbox that we can use for finding solutions to the SDGs. I think ultimately what's really required is a change in behavior, culture, and practice as well. This very much relates to governance and management issues. It's a people problem and how we work together ultimately. So I think we need to better understand the problem first, and in order to adopt the space technologies rather than adopting technologies for the sake of technologies, and ultimately to make more impact and to foster better and more efficient use of these space technologies. Thanks again.
Thank you very much, Su-Yin and Kris.
Thank you. I'd like to conclude with a challenge for everyone here and everyone listening, as well as myself, and that is that everything we develop for space applications almost always can have a ground application, and vice versa. Everything we do on the ground may potentially have space applications, and it's simply our job to find them all. And so at every opportunity, I would challenge us all to look at what we do to better life on Earth, look at what we do to better life in space, and find ways that they can cycle between each other, so that we can make sure that we always make sure that space has Earth benefits and vice versa. Thank you.
Thank you so much. If you still have 1 minute, then we are. I have in the chat that the class of EPFL wants to say something, or at least one person.
So on behalf of EPFL, we'd like to thank the panel for accommodating us, answering our questions, and we promise to meet that challenge, Kris. And huge thanks to the professor too for organizing this really cool hybrid class.
Okay, thank you. So I have to do two things. First, I have really to thank my distinguished panel, and I think this was really a joy, and I hope that's recorded and other people can see that and listen to it, because it was so clear and open in many aspects and so informative. I really want to thank you that you have taken the time. And the other thing is that I have to announce the sessions which happens in 2 hours on space science, technology, exploration, and civilian development. So I guess because we are in US time, there is now some lunchtime or something like that. And then it continues again at 8 p.m. CEST, but that would mean 2 p.m. EDT or something like that. Maybe Kim, you do that, because I don't get the times wrong.
It's Dr. Foing himself will be the chair,
okay,
or the moderator of the session, and it is 2 through 5 p.m. New York time zone.
And for all the Europeans at 8 p.m.
And for the world, 6 p.m. Universal time.
Universal time. Okay, good. Now we have all time zones. Yeah. So I want to thank all the organizers, and of course Joe Pelton and Kim and everybody who is behind that we have absolutely no glitch, and that we had a very smooth session. And I hope we do that again. I thank you really all very much for your time.
Thank you.
Bye bye.
Bye, everybody. Thank you again.
Bye, everybody.
Bye, thank you.
I'm going to end it now.
Good night, and thank you. I look forward to talking to some of the moderators here in Adelaide, Australia. With the space agencies here, we're working on quite a lot of stuff in regards to fire safety and emergency services protocols. Thank you again.
Thank you.
Goodbye. Thank you.
Congratulations. I voted.
And I don't know if you've seen my communication. I will be, I sent a message to Pilar inside and via email, inside their software and via email, that I will be your
No,
co-host.
you're the host. You can save the recording at this point
All right. I will do that.
on your computer.
Yeah, I had to choose at the beginning, my computer or UNGA Science Summit Cloud. And we'll see what happens. See you in a couple hours.
Okay, thank you very much.
Thank you. Mhm.